Kenny. Manag-aral tang ulit bang mabiyasa? Allow me to guide you in learning the different concepts and skills in Mathematics 9. I am Teacher Andrew, your soulmate. Ready your self-learning modules and learning activity sheets. Hebraetin is doing an activity called Follow My Path, where she has to sketch the graph of a given function by following a map. The map looks like this. Let's try to do it also. We begin by rewriting the quadratic function y equals negative x squared plus 4x plus 1 in vertex form. We should write in the box the steps we have to take. We must separate the terms with a variable from the constant term, hence the parenthesis. Next, we factor out the coefficient of x squared, which is negative 1. The equation becomes y equals the negative of the binomial x squared minus 4x plus 1. We complete the square by adding to the binomial in the parenthesis the square of half of negative 4, which is 4. Then, we subtract from the constant term 1 the product of 4 and the leading coefficient, which is negative 1, which is why there is a negative sign beside the open parenthesis. The product of 4 and negative 1 is negative 4, so we subtract negative 4 from the constant term 1. The equation can be rewritten now as y equals the negative of the square of the binomial x minus 2 plus 5. And this is already the vertex form. The ordered pair 2, 5 describes the vertex of the parabola that corresponds to the function. We now proceed to the next part, which is completing the table of values. Notice that the middle pair is already given, and this is in fact the pair that describes the vertex of the parabola. Moving forward, when x is 0, y is equal to the negative of the square of the quantity 0 minus 2 plus 5, and this must be equal to the negative of 4 plus 5, and the result is 1. When x is equal to 1, y is equal to the negative of the square of the quantity 1 minus 2 plus 5, and the result is the negative of 1 plus 5, or simply 4. When x is 3, y must be equal to the negative of the square of the quantity 3 minus 2 plus 5, which must be equivalent to negative of 1 plus 5, and the result is 4. Lastly, when x is 4, y must be equal to the negative of the square of 4 minus 2 plus 5, and this is equal to the negative of 4 plus 5, and the result is 1. Hence, we have 5 ordered pairs: 0, 1, 1, 4, 2, 5, 3, 4, and 4, 1. Alright, we now go to the third and last part. We have to plot the points described by the pairs in the table of values. And this is what the Cartesian plane looks like when these 5 points are plotted. To make the vertex more prominent, you would see the ordered pair 2, 5 above it. Then, we connect these points to sketch the parabola. And we're done. Let's hope and pray Hebraetin will also be able to accomplish the task. Let's see the graph once more. The vertex form of the function shows us that the value of a is less than 0, as indicated by the negative or minus sign beside the open parenthesis. This means that the parabola that corresponds to the function opens downward. And as seen on the graph, the direction of the opening of the parabola is indeed downward. And a while ago, upon rewriting the equation for the function in vertex form, we were able to immediately identify the vertex of the parabola. And it is described by the ordered pair 2, 5. Why 2? Because in the parenthesis, x is subtracted by 2. Why 5? Because outside the parenthesis, is the constant positive 5. When a parabola opens downward, the function has a maximum value, and it is given by the y-coordinate of the vertex, which is represented by the variable k. Hence, the given function's maximum value is 5. Since a quadratic function is a polynomial function, its domain, the values of x or of the independent variable for which the function is defined, is the set of all real numbers. This is true for all quadratic functions, whether they correspond to parabolas that open upward or to those that open downward. However, the range of a quadratic function varies. The range of a quadratic function is the set of values of the function or of the dependent variable. For a quadratic function whose graph is a parabola that opens downward, its range is a subset of real numbers denoted by the inequality y is less than or equal to k. It means that the value of the function or of the variable y is less than or equal to the y-coordinate of the vertex represented by the variable k. So, the range of the given function here is given by the inequality y is less than or equal to 5. Looking at the parabola, you can see that indeed the highest y value included in the parabola as a y-coordinate is 5. All the rest are below 5. All parabolas intersect the y-axis, and the number at which the parabola intersects the y-axis is called the y-intercept. This y-intercept is obtained when the value of x or of the independent variable is set to 0. If the function is in the form y is equal to ax squared plus bx plus c, y-intercept is equal to c. If the function is in vertex form, the y-intercept is equal to ah squared plus k. In the given function that we rewrote in vertex form, its y-intercept is equal to the negative of the square of 2 plus 5 equals negative 4 plus 5 equals 1. And this is equal to the constant term in the general form of the function. When a parabola intersects the x-axis, the parabola has x-intercepts. X-intercepts are obtained by setting the value of the function to 0. Hence, we have to solve a quadratic equation. Its roots will be equal to the function's x-intercepts. If the function is in vertex form, we can solve the resulting equation by extracting square root. As an example, let's identify the x-intercepts of the given function. Step 1. Applying symmetric property, the equation becomes the negative of the square of the binomial x minus 2 plus 5 equals 0. Step 2. Subtracting both sides by 5, the equation becomes the negative of the square of x minus 2 equals negative 5. Dividing both sides by negative 1 for step 3, the resulting equation is the square of x minus 2 equals positive 5. Step 4, by square root property, this means that x minus 2 is equal to positive or negative square root of 5. And step 5, adding both sides by 2, we obtain that x is equal to 2 plus or minus the square root of 5. In radical form, the two x-intercepts are 2 minus the square root of 5 and 2 plus the square root of 5. But when renamed as decimal, rounded to the nearest thousandths, these x-intercepts are approximately equal to
negative 0.236 and 4.236 respectively.
Lastly, there is a line that divides the parabola into two so that one half of it is a reflection of the other. This line is called axis of symmetry, a vertical line that is described by the equation x equals h, where h is the x-coordinate of the vertex. the parabola that represents the function y equals the negative of the square of x minus 2 plus 5 is divided by the axis of symmetry x equals 2. As a summary, let's see this table. Given a quadratic function written in general form, it can be rewritten in standard or vertex form. And if a is less than 0, the following are the characteristics of the function and its graph. First, the direction of opening of the parabola is downward. Second, its vertex is described by the ordered pair hk. Third, the function has a maximum value which is equal to k. Fourth, its domain is the set of real numbers. Fifth, its range is the set of all y that is less than or equal to k. Sixth, the y-intercept is equal to the value of the coefficient c in the general form. It is equal to the value of ah squared plus k if we are going to base it on the vertex form. Seventh, the x-intercepts are obtained by solving the equation ax squared plus bx plus c equals 0, derived from the general form, or by solving the equation a times the square of the binomial x minus h plus k equals 0 that is derived from the vertex form. Lastly, the axis of symmetry is described by the equation x equals h. This time, let's have an example where the value of the coefficient a is positive. We have the function y equals 2x squared plus 12x plus 15. When expressed in vertex form, y will be equal to 2 times the square of the binomial x plus 3 minus 3. Since the leading coefficient is 2, which is positive, the parabola that represents the given function opens upward. Let me show you the graph of the function. The vertex of the parabola is given by the ordered pair -3, -3. The binomial in the parenthesis, which is x plus 3, is the simplified form of x minus -3. X is minus -3, hence h is equal to -3, and k is of course equal to -3, since the constant outside the parenthesis is -3. When a parabola opens upward, the function has a minimum value, and it is given by the y-coordinate of the vertex, which is represented by the variable k. Hence, the given function's minimum value is -3. The domain of the function is also the set of all real numbers, while its range is a subset of real numbers denoted by the inequality y is greater than or equal to k. It means that the value of the function or of the variable y is greater than or equal to the y-coordinate of the vertex represented by the variable k. So, the range of the given function here is given by the inequality y is greater than or equal to -3. Looking at the parabola, we can see that indeed the lowest y value included in the parabola as a y-coordinate is -3. All the rest are above -3. The y-intercept of the function, if we compute it based on the vertex form, y must be equal to 2 times the square of -3 minus 3. And it is equivalent to 2 times 9 minus 3, which results to 18 minus 3, and hence the y-intercept is 15. The x-intercepts can be computed by setting the value of the function to 0 and then solve for x. We may use the general form of the function. Hence, we have to solve the equation 2x squared plus 12x plus 15 equals 0. Let's use the quadratic formula. See the computation. In radical form, The intercepts are written as -6 minus the square root of 6 all over 2 and -6 plus the square root of 6 all over 2. When renamed as decimals, rounded off to the nearest thousandths, these are approximately equal to
-4.225 and -1.775 respectively.
Lastly, the axis of symmetry is also described by the equation x equals h, where h is the x-coordinate of the vertex. In the parabola, the axis of symmetry is the line x equals -3. As a summary, let's see this table. Given a quadratic function written in general form, it can be rewritten in standard or vertex form. And if a is greater than 0, the following are the characteristics of the function and its graph. First one, the direction of the opening of the parabola is upward. Its vertex is described by the ordered pair hk. The function has a minimum value which is equal to k. Its domain is the set of real numbers, while its range is the set of all y that is greater than or equal to k. The y-intercept is equal to the value of the coefficient c in the general form, while it is equal to the value of ah squared plus k if we are going to base it on the vertex form. The x-intercepts are obtained by solving the equation ax squared plus bx plus c equals 0 derived from the general form, or by solving the equation a times the square of the binomial x minus h plus k equals 0 that is derived from the vertex form. And lastly, the axis of symmetry is described by the equation x equals h. Kagamath, ready your paper and pen. It's math the moment. Given the function y equals the square of x minus 5 plus 3, do the following. A. Complete the table of values. B. Sketch the graph of the function. And from C to I, identify the following characteristics of the function and its graph. For C, direction of the opening of the graph. For D, vertex. For E, domain. For F, range. For G, x-intercepts. For H, y-intercept. And for I, axis of symmetry. You have 3 minutes. Go! Time is up. Here are the answers. The table of values, when completed, must contain the following y values. The parabola should look like this. For items C to I, here are the answers. For C, upward. For D, the ordered pair 5, 3. For E, X is the set of all real numbers. For F, Y is greater than or equal to 3. For G, there are no X intercepts. For H, 28. And for I, X is equal to 5. And that has been a fruitful discussion with you, Kagamat. Let me end on this note. When you raise your arms, be reminded that you have the power to uplift not only yourself, but other people as well. When you position your arms in a way that there is a space between your arm and your waist, be reminded that you are not alone. There are people whom the Lord has assigned to you who will stay with you through ups and downs. See you on the next Mathathon, Kagamat. Bye!